Let's start with some definitions. A joint event is an event that has two or more characteristics. For example, getting two heads when you toss a coin twice. So the first event would be heads on the first toss, and your second event would be heads on the second toss. So the word joint, a single event would just be getting a head that first time you toss the coin. Complement of an event. A. Majority of the textbooks write the complement of an A like that, and that's called A bar. And it includes all events not in A. But I have seen textbooks that use this notation, like A prime. If you take all the events in A plus all the events not in A, it will always give you 1. So the example I gave you is the probability that I catch a cold is 0.05. The complement would be 1 minus 0.05 or 0.95, which would represent the probability that I do not catch a cold. The sample space, that's a collection of all possible events. Okay, so the sample space for tossing a coin one time would be either a head or tail. If you're tossing a coin 2 times, you'd have to list all the, it might be a head and a head, or a head and tail, or a tail and a head, or tail, all those events would be part of the sample space. Mutually exclusive events. 2 events are mutually exclusive if both events cannot occur simultaneously. So let's look at some probability formulas. In some textbooks, you'll see, no, we're not doing probability yet. We're doing examples of if they are mutually exclusive events. All right, determine which of the following are mutually exclusive. I want you to draw one card out of a deck of cards. And what is the probability of getting a king, getting a diamond? Could that happen at the same time? Could you get a king and a diamond by pulling out one card? And the answer is yes. You could get a king of diamonds. So these are not mutually exclusive. Okay, you're going to pull one card out. Could you get a 4 and get a king at the same time? No, you couldn't. So these are, yes, they're mutually exclusive. A face card is a king, queen, jack. Could you pull one card out and get a face card and get a club? So are those mutually exclusive? You could pull out a jack or a queen or king of clubs. So these are not mutually exclusive. Those could happen at the same time. Getting a face card, king, queen, jack, or getting a 10. That couldn't happen at the same time. So those are, yes, mutually exclusive. Now, if you know you have mutually exclusive events and you want to find the probability of A or B, then it would just be the probability of A plus the probability of B. That's a formula if you know you have mutually exclusive. I do not use that formula. I always use, these are all the same. All these are equivalent. I always use, if I'm trying to find probability of A or B, that's a probability of A plus probability of B minus the probability of A and B. If you have mutually exclusive events, this last probability will be 0. If you always use this formula, in case you've double counted, this formula will take care of it. So I discourage you to even think about this one here. Always use this general addition rule. Now, let's talk about notation issues. Instead of having the word or, you can have the union symbol, and you could have the intersection symbol for and. The other thing you could do, you could actually have the ampersand, the and symbol, to represent that intersection. All right. find the probability in context to a deck of cards. If you're not familiar with cards, there's 52 total cards, and you have 13 hearts, 13 diamonds, and they're both red, 13 spades, and 13 clubs. These last two are black, these are red. All right, now watch. I want to find the probability of a 4 or jack. Now what I will always do is write this out in one of these forms, okay? I want to find the probability of 4 or jack. I'm pulling a card out. What's the probability? It's 4 or jack. Well, it's the probability of a 4 plus the probability of a jack minus the probability of 4 and jack. Well, what's the probability of 4? Well, it's going to be over 52 because that's how basic probabilities work. You have your total possibilities in the denominator, and the numerator will answer the question. In other words, I'm trying to find the probability of 4. How many 4s are in that deck of cards? And there's 4. All right. What about the probability of a jack? Well, how many jacks are in there? You still got 52 cards, and you've got 4. Minus, you pull a card out. What's the probability you pull out a 4 and a jack? You can't do that, so that's going to be 0. So you got 8 over 52. Reduce that down, 2 divided by 13. You can use decimals or fractions. I believe in these examples, I'm going to leave everything in a fraction. Probability of 5 or 6. Write it out. That's a probability of a 5 plus the probability of a 6 minus the probability of a 5 and 6. See, I don't even have to think about at the very beginning which formula to use. I don't have to think about if they're mutually exclusive by using this general probability rule for addition. Probability of 5, that's going to be 4 over 52. How many 6s are in there? Total 52 possibilities. There's 4 of them. And minus the probability of a 5 and 6. It's 0 because you can't pull out a 5 and a 6 on one card. So that is 4 over 52 plus 4 over 52, which gives you 8 over 52. Let me erase that so it looks a little bit. 8 over 52, and that's 2 over 13. Probability of a 3 or heart. Write it out. It's a probability of 3 plus the probability of a heart minus the probability of 3 and heart. I'll try to mix up my notation. A probability of 3. How many cards do I have? 52. How many are 3? There's 4 of them. Hearts. Well, total possibilities, 52. How many hearts are in a deck of cards? That would be 13. Minus probability of pulling out a 3 of hearts. Well, there's only one. There's total 52 possibilities, but how many cards can you do that? Pull out a 3 of hearts? Yes. There's one of them in that deck. Because see what happened? When you counted here, one of those 3s was a heart. And when you counted here, one of the hearts was a 3. So you've counted it twice. That's why you want to subtract out off that 1 over 52. And that gives you 16 over 52, which is 4 over 13. Jack or clubs. Jack or club. That's a probability of a jack plus the probability of a club minus the probability of jack and club. Probability of a jack, 52 there. There's 4 of them in there. Plus probability of a club. There's 52 there, and there's 13 of them. How about probability of a jack and club? There's 1 of them in there. Once again, one of these jacks was a club. One of these clubs was a jack. So that's going to give you 16 over 52, which is 4 over 13. see what we have next. Ah, yes. If you'll read that. All right, so we need to organize our data. We've got nurses and we have doctors. And I've got females and males. And what am I trying to find? Find the probability that the subject is a nurse or male. Trying to find the probability of nurse or male. All right, in a hospital unit, there are 8 nurses. Well, that means if I was to sum up the first row, this would be 8. And 5 doctors. Well, this would be a 5. Okay, in a hospital, there are 8 nurses and 5 doctors. 7 nurses and 3 doctors are female. 7 nurses are female. 3 doctors are female. It goes in that spot. If a staff person is selected, find the probability that the subject is a nurse or male. Well, we have a total of 8 here, so that means this must be a 3. And a total of 5 here, that means this must be a 2. So we got a total of 13 people, and that makes sense. You got 10 females and 5 male. Oops, is that right? I've messed up somewhere. Oh, this has to be a 1. 7 plus 1 is 8. So 1 plus 2 is 3. Now see how that was a good check? I'd made a mistake. I wish I could say I made it on purpose, but I didn't. But it made sense because I had 8 plus 5 is 13. And well, it didn't make sense because it wasn't adding up to 13 in this bottom row for totals. All right, I'm not going to redo this video because I messed up. So probability of nurse plus probability of male minus probability of nurse and male. Probability of a nurse. Well, we got 13 to choose from, so that's going to be 13 in the bottom. And how many are nurses? 8. Plus the probability of a male. Well, we got 13. Oops. We got 13 of them. 13 people. How many are male? 3. 3. Minus the probability of nurse and male. Well, nurse and male is this right here. One of them, because that one's already been counted. So we're going to back it out. And that gives me 10 over 13.